Hi, this is Margo. This is Sunday evening, July the 10th, 2022. I hope everyone is safe and doing as well as possible. We got through another week and it's getting harder all around for everybody. And so I'd like to welcome everyone to the show today. This will be my weekly update that I'll be putting on YouTube. We're going to go over methane, sea ice, and climate-related items for the week. I'm going to start off with a couple of articles. This one is from The Guardian, and this came out a few days ago, and the title says, "Methane much more sensitive to global heating than previously thought," from a study. And it says greenhouse gas has undergone rapid acceleration, and scientists say it may be due to atmospheric changes. Well, how about everything heating up and the permafrost thawing and stuff coming up from the Arctic Ocean and all of that. And it says methane is 4 times more sensitive to global warming than previously thought, a new study shows. The result helps to explain the rapid growth in methane in recent years and suggests that if left unchecked, methane-related warming will escalate in the decades to come. Well, this is news to them, I guess. The growth of this greenhouse gas, which over a 20-year time span is more than 80 times as potent than carbon dioxide, had been slowing since the turn of the millennium, but since 2007 has undergone a rapid rise, with measurements from NOAA recording it passing 1,900 parts per billion last year, nearly triple pre-industrial levels. Well, it's over that now. It has been for a while. What has been particularly puzzling has been the fact that methane emissions have been increasing at even greater rates in the last 2 years, despite the global pandemic, when anthropogenic sources were assumed to be less significant, said Simon Redfern, an earth scientist at Nanyang Technological University in Singapore. No, it's baked in the cake. And there are natural sources of methane, not just anthropogenic, but they don't count the natural sources. And then he says about 40% of methane emissions come from natural sources, such as wetlands. Well, that's the only thing he says about natural sources, while 60% come from anthropogenic sources, such as cattle farming, fossil fuel extraction, and landfill sites. He left out termites and rice fields. Possible explanations for the rise in methane emissions range from expanding exploration of oil and natural gas, rising emissions from agriculture and landfill, and rising natural emissions as tropical wetlands warm and Arctic tundra melts. But another explanation could be a slowdown of the chemical reaction that removes methane from the atmosphere. The predominant way in which methane is mopped up is via reaction with hydroxyl radicals, or OH, in the atmosphere. The hydroxyl radical has been termed the detergent of the atmosphere because it works to cleanse the atmosphere of harmful trace gases. But hydroxyl radicals also react with carbon monoxide, and an increase in wildfires may have pumped more carbon monoxide into the atmosphere. May have, and altered the chemical balance. On average, a carbon monoxide molecule remains in the atmosphere for about 3 months before it's attacked by a hydroxyl radical, while methane persists for about a decade. So wildfires have a swift impact on using up the hydroxyl detergent and reduce the methane overall, reduce the methane removal. To understand what was driving methane acceleration, Redfern and his colleague Chen Hsian Ching used 4 decades of methane measurements and analysis and analyzed changes in the climate to identify how the ability of hydroxyl radicals might have changed and what impact the changing climate might have had on methane sources. Their findings, published in the journal Nature Communications, suggest global heating is 4 times more influential in accelerating methane emissions than previously estimated, with rising temperatures helping to produce more methane by speeding up microbe activity in wetlands, for example, while at the same time slowing down the removal of methane from the atmosphere. With increasing numbers of wildfires reducing the availability of hydroxyl radicals in the upper atmosphere. It was a really shocking result and highlights the effects of climate change that can be even more extreme and dangerous than we thought, said Redfern. So it goes on for a while. So you get the picture. So this is all new information that has not been figured into all of their previous forecasts and everything. So 4 times more with and it creates a feedback loop that just keeps going. So it's 4 times worse. So the heating will be 4 times worse too. So there you go. And this is why I do daily reports on methane. And then from Site News, huge all-season ozone hole discovered over the tropics. This is news to these people. I've been showing it though. Anyway, University of Waterloo's Professor Qingbin Liu has discovered a large all-season ozone hole in the lower stratosphere over the tropics from 30 degrees north to 30 degrees south. The depth of the tropical ozone hole is comparable to that of the well-known springtime ozone hole over Antarctica, while its area is about 7 times that of the latter. Well, I've been showing this in every report. Anyway, it gives a bunch of background. And it says the existence of the tropical ozone hole may cause a great global concern. Well, no one's concerned yet. It says the tropics constitute half the planet's surface area and are home to about half of the world's population. The discovery of the whole-year ozone hole over the tropics came as a surprise to the scientific community, since it was not predicted by conventional photochemical models. No, but you can look at CAMS and see that it's going away. So, with the whole, you've got ozone depletion, UV radiation change, increased cancer risks, and other negative effects on health and ecosystems in the tropical regions. But it's growing, it's not just in the tropics. And so I'll show you. I'm just going to show this in a minute here. Let's see. Here it is. See, here it is today. This is from CAMS, and this is total column. And so he's talking about 30 degrees north. That's 30 degrees north of the equator, which is right here is the equator. So 10, 20, 30. So that reaches up to about the southern U.S. border. And it goes through northern Africa and through northern India and through China. And then 30 degrees south, 1, 2, 3, goes through most of Brazil, most of Africa, a lot of the Indian Ocean, the top part of Australia. And so it encompasses, here I'll zoom in so you can see it. It encompasses like all of these South Pacific islands, Indonesia and Philippines, Papua New Guinea, and you see the aqua there. That's even lower than the green. So anywhere you see the green, they're considering that part of this year-round hole. And we've got aqua over Peru and Chile here. And see the greens, all the greens. That's part of the hole. And it encompasses the whole planet from the equator up and down. And you see we're getting holes further north too. We've even got a hole here in Siberia and over the Arctic today. Here, see? And so the wildfire smoke is eating up the ozone. And last week I talked about the Alaska wildfires, and they're still billowing away, and the smoke is now has moved over all of Alaska and a lot of Canada, and is all over the Beaufort Sea and all of this Canadian archipelago. And we've also got this hole here over Siberia over to Kamchatka. That's today. And let's go back. I'll show you while we're here. Here's the Antarctic ozone hole. And we're not down into what's considered the danger zone, but it's still a huge hole. And it's in the greens, and it's over all of the Antarctic, and see the break coming up there towards Australia, I think that is. So there's that. And so I'll leave the link below so y'all can look at that. And let's see if there was more we wanted to look at in this. The depletion of the ozone layer can lead to increased ground level UV radiation, which can increase risk of skin cancer and cataracts in humans, as well as weaken human immune systems. Well, it unwinds the DNA, is what it does. Decrease agricultural productivity. Well, it burns the plants, they can't grow. And negatively affect sensitive aquatic organisms and ecosystems. So there's that. And since, I don't know, in the last 6 months I've been showing ozone in every report as well. So there you go. So we're going to start with Climate Reanalyzer. This is 2 meter temperature today. Look at all these greens over the Arctic. That's all above freezing. The dark green is about 5 to 8 degrees Celsius. The light green is 10. Where it's moving out there, and where it's moving towards the aqua color, this is like 3, maybe 3 degrees Celsius. And these whites, these are above around 100 degrees or higher. See, from Texas up through the Midwest, and then from Mexico up on the west side there. Here's the flat view. Look, we've got some white here in the Congo. That's got to be miserable. And then across Africa, Saudi Arabia, Iran, and so on, India. We've got white here at Spain and Portugal today. Here's 2 meter temperature anomaly. And we can see Alaska is all in the brown. Northern Canada and the archipelago is brown, moving into the red zone. The dark red, that's about 16 C, higher than normal. And then we've got browns coming up in the Atlantic over the Barents Sea and the Kara Sea, and over Russia, here Kamchatka, and so on. Then the blues are right next to it. That's where the cold air is not being held in, because we have a loopy jet stream now. It broke last year. See the browns? there. Worldwide, we're up 0.2 C higher than normal. The northern hemisphere is up 0.5 C. The Arctic is up 1 C. The Antarctic is down 2.2 C. Southern hemisphere is down 0.1 C. And the tropics are up 0.2 C higher than normal. Look at South America. See, that's burning up. Here's what we used to call the jet stream, but it looks like loops, jet loops. See, look at it here in the southern hemisphere. They've got 3 or 4 here going on. And sea ice and snow cover. I guess someone from Climate Reanalyzer is watching my shows, because they started showing some change this week in the ice. Now, this big hole in the Beaufort Sea, that's not reflected in any of the other models. The Beaufort Sea is thinning and is coming apart, but this is the only model showing a big hole right there. You can also see a noticed decrease in the extent. Also here in the Baffin Bay, Hudson Bay, it's almost all gone, and a lot of open water here in the Laptev Sea, and inching out these little ears, inching out here, and going in here at the Chukchi Sea. Here's sea surface temperature anomaly. This is as of yesterday, the 9th. And this is looking worse every day. Now, the sea ice is in high melt here in the Arctic, and wherever it's already melted and there's open water, we're seeing it's heating up really fast, and like the browns, or like the light brown here is 2C higher than normal. The dark brown is about 5C high, 3C. The reddish brown is about 4C. The bright red is about 5C. And then the pinkish color into pinkish white is about 6C higher than normal. And we're even seeing that here in the Kara Sea. And so all around this Russia coastline, where the Atlantic's coming up, that's all brown now. And it's brown here in the Laptev Sea, brown and red here in the Bering Strait, here in the Chukchi Sea, and look around Alaska, look around Kamchatka, it's into pinks and reds. And here in the Hudson Bay, that's already in the browns. And we were still seeing some sea ice in a lot of this Hudson Bay just last week. And now, see, as soon as it melts, it's going into the browns. The Great Lakes are moving into the browns. Gulf of Mexico is all brown. Here's the flat view. Here are interior bodies of water are heating up. This Mediterranean is reddish, brown, and red. Here's the Black Sea, that's almost all brown. Here's the Baltic Sea, that's brown and red. And here next to Japan, that's reddish brown. And then we've got reds coming up and around. Look at this. The Sea of Okhotsk, it's the winter. This area around Kamchatka is the winner for the highest, the most and the highest readings here. And then we've got browns all around Australia. Browns coming across the Pacific. And we've got just a little blue here in the Indian Ocean and here in the Pacific. Worldwide, we're up 0.4 C, higher than normal. Northern Hemisphere is up 0.6 C. The North Atlantic is up 0.3 C. And the North Pacific is the winner, up 0.8 C, higher than normal. I don't remember when I've seen it that high. Southern Hemisphere is up 0.2 C. And the equatorial Pacific is down 0.2 C, lower than normal. So there's that. Now we'll move on to methane. I have 2 days worth of methane to show. We're starting with NOAA. This is from Friday the 8th in the morning. Met.B or Met.1 satellite, and we're tracking this 469 millibar reading. That's about halfway up in the atmosphere. The mean or average was 1927 parts per billion. The high reading was 2383, and we've got pinks coming as far south as the Antarctic there. And we look at all this missing data. Almost all of South America is missing. So here the mean is 1927. It would be higher if we had South America in there. And the high reading was 2344. And then for yesterday, the 9th, here the mean was 1926. In the morning, the high reading was 2340. In the afternoon, the mean was 1927. And the high reading kind of spiked at 2525. Here's our spreadsheet and chart. And so the 9th averages out to be 1926.5 parts per billion. So we had an overall decrease this week of 1 part per billion. And so here the line just went down a little bit. And you know, it looks like we're kind of getting off to a slow start with the methane rise. I mean, it's on the increase. It's just kind of stair-stepping. And we're 11.5 parts per billion higher than a year ago. And we're 57 parts per billion higher than when I started tracking this way back here on March the 1st of 2019. And you can see that with each passing season, it's higher than the year before. And then when it goes down in the winter time, it doesn't go down to the previous low. And so it just keeps going. And let's see what happened this week. Here we were in our show last week. On the 2nd, we were at 1927.5. And we had gone up 1.5 last week. And so on the 3rd, it went up 1 part per billion. No change on the 4th. On the 5th, it went down 0.5. On the 6th, it went down 1.5. On the 7th, it went down 1 part per billion. On the 8th, it jumped up 1.5. And then on the 9th, it went down 0.5. So, just stair-stepping. And so we're 1 part per billion lower than last week. Now we'll move on to cams. And we're looking at Saturday, July 9th, Arctic view and surface level. Here's our color chart at the bottom. So the data is for Saturday, and forecast period is Sunday through Wednesday. Getting kind of a late start, but we'll get this done. So the data is for Saturday, and the forecast period runs Sunday through Wednesday. I don't know if I said that or not. So it's popping off here at Iceland, and here it's still percolating here in our problem spot in the North Atlantic off the Canada coastline. We've got a little wave of blue coming through, which is a little lower reading. And from Norway over to Russia, it's still looking really heavy. Now, it was awful earlier this week, and it was coming up off the coast, from the sediment there, really billowing. And we can see this interior of Russia is coming back to life. Komsomolets is billowing again, for whatever reason. I think it was just being suppressed for a short period. And here it's bubbling in the Kara Sea, North Kara Sea. We're also seeing higher readings on the coastline. Watch right here where my pointer is. You'll see. Look, watch. There it comes. That was right at the end of the forecast period. And see the waves of the green and the yellows moving across. That's methane coming up through the sea ice. Here it is from Alaska, Canada, Now we'll go to the North Pole view. Here we can see the northern hemisphere. Look at this, the UK, Ireland, just a big blob, over to Germany, and then south, this is France, and then Italy comes right in up there. Here's the Persian Gulf, that's really heavy. India, China, here's Korea, up. See, these high readings are coming up to northern China, and then here it meets up with Russia. And then here in the US, we've got huge areas of blobs, just super high. See? The reason it pulsates like that with the lower readings and the higher readings is because it goes down when it's nighttime on that area. Then when the sun comes up and it heats up, then it's showing higher readings. Now we'll hop down to the Antarctic. Look at this. This is not good. So we've been seeing more of the higher levels of methane encroaching down here. See? Look at this. All along this coastline, I think it's just overall higher readings now as things are kind of heating up and the methane is redistributing around the planet. It goes through its seasons of distribution. And so our main background color is this 1840, and we're seeing 1860 see coming down through the Atlantic. It's coming up all along this western peninsula, and here the Brunt ice shelf. Look at it all along this eastern coastline. And it's also streaming down from Africa, Australia, here South America. So I'm thinking that this 1860 is going to overtake the 1840 as our main background color. Maybe within a week. I don't know. I mean, it's going fast, it looks like. Okay, here's the global view. Look at this. See this whole. So the Atlantic is almost all, at least this 1860 and higher. Here it is coming down off of Africa and Australia, New Zealand, and it's these generally higher, creeping out, kind of overtaking the Pacific. Now it is a little lower in this Pacific area because of the colder water there, I think. Equatorial Pacific. Australia, look at this. Now we'll go to 500 HPA. Look at this. And see, the heaviest here is over northern India, over into southern Asia, also coming across Iran, Persian Gulf, Saudi Arabia, the Red Sea. So that's kind of spreading out, and we have higher readings here over Barents Sea, Kara Sea, and North Atlantic, also over the Arctic, and our yellows are kind of creeping, they're kind of overtaking this whole southern part, some shade of yellow. And total column. And see, China, all the way across to India, Persian Gulf. So normally we don't see it all the way over here with that heavy reading over the way to Saudi Arabia. Normally it's kind of over China, but it's spread out. Alright, now I'll just show you the rest of these. Here's the smoke. I've been tracking this too. This is the Arctic view. This is off of cams. Here it is in Russia. This is from the fires, and see how it's kind of streaming east. Here it is over Alaska from the interior, and it's going north and east, and see over Canada, this whole archipelago region, all the way across the Beaufort Sea, and then swooping down across Canada and the Hudson Bay. So it's a large area that's really got a lot of smoke right now. Here's sulfur dioxide today, and nothing's just jumping out at me. Here it is at 500 HPA. It's not just huge readings. And we saw ozone already. So there's that. I'm going to close this one. Now we'll move on to sea ice. And I'll just show this. I mean, I track this. Whatever their model shows, I track it. I don't always agree with it, because I look at other models as well. So we already saw this on the website. This is sea ice and snow cover today in the Arctic, and thinning out here above Greenland. Now we've been getting rain across the Arctic, different regions this week, and up here north of the North Pole there are holes opening up. Here this Kara Sea is open from Novaya Zemlya over to the coastline. Still some sea ice in the North Kara Sea up by Severnaya Zemlya, and here's where it's opened up in the Laptev Sea and around New Siberian Islands, thinning around the coastlines greatly. And then they're showing this great big hole in the Beaufort Sea, and these tributaries are melting out. So let's see the big change since last week. So here we were last Sunday, and that's when I said I didn't think they were changing their model because it didn't match the other models. So it was just looking the same every single day. So here we were last Sunday, the 3rd. Here's the 4th. Look, no change. Here's the 5th, no change. Here's the 6th. We started to see a little hole open up here in the Laptev Sea. The 7th, 8th, not much change. Look at that. Here's the 9th. So someone updated something from the 8th to the 9th. Now we didn't have all that ice loss in one day, trust me. Look at that. And then all of a sudden, big hole. And here we are today. So I just found that kind of amusing. Now we'll move on to our other models. This is the U.S. Navy sea ice model. This is the Arctic sea ice thickness. And the only views they're updating are the Arctic and the Antarctic views. They're not updating the Beaufort sea ice view, Baffin Bay, or the Ross Sea. June 28th was the last update on those, for whatever reason. I would think, with us being in the middle of the melt season, they would at least be updating the Beaufort Sea, but they're not. So here we are today, and our chart is on the right. The lavender, the light lavender is about 1/2 meter thick. The dark purple into blue is about 1 meter thick. The dark aqua is about 1.5 meters thick, like around this edge. And the bright aqua, like this line above Greenland and Canada, that's about 2 to 2.5 meters thick. The green is about 3 meters thick. Whatever yellow is about 3.75 meters thick. Bright red is about 4.5 meters thick, and if you see any dark red, that's up to 5 meters thick. So Here the Hudson Bay is almost all cleared out. The Baffin Bay is in high melt. This whole west side of Greenland has melted out. The east side is melting down. Svalbard is open. Here we'll zoom in. And this edge is melting down. Here's Novaya Zemlya. They're showing a little fringe of ice here on the east side. Kara Sea is open for the most part. And coming around, we've got open water coming through along this Taimyr Peninsula and opening up here in the Laptev Sea. Here are the ears that we saw where it's opened up. And along the coastline it's opening up. Got a little bit of thicker ice here in this East Siberian Sea. And Bering Strait is open. The Chukchi Sea, that's melting in fast. And here's the Beaufort Sea. I don't see anything that resembles what we saw on Climate Reanalyzer here in the Beaufort Sea. It's thinning. It's down to dark purple here, but we don't have a big huge hole coming across. Not in this model. And open here along Canada. Let's zoom in a little more. So we're seeing just a little hint of red and dark red. I mean, just a little sliver here along this island, along Ellesmere Island and the north coast of Greenland. You can see where it's melting out in the tributaries. And this is an exit point for a lot of the sea ice. It can get driven down into these cubby holes and then just flows out if it's not frozen in there. Here's some green along Canada. Just a little sliver of green next to Greenland. Here's the North Pole. So the big thing is it's thinning out a lot. We're starting to see open water in a lot of places. Here's the 30-day animation. This was updated to yesterday. So the data goes back 3 weeks and the forecast period goes out to next Saturday, the 16th. So let's zoom in and watch this. Wow, look at that. Look at how it thins down. It's in high melt. Now the smoke over the sea ice is very bad because the particles, the particulates, particles and soot and ash falls down on the sea ice. It also is acidic. And so wherever it falls down on the sea ice, that'll melt out really fast. and it creates a dark layer on the ice, and so it's not as reflective, and so it's absorbing more light. Granted, there's smoke, but there's still light coming through. Look at that. Let's watch these tributaries. Yeah, you can see it flowing out and melting. So that thicker ice is really thinning down. Okay, here we are at the end of the forecast period, 16th, and they're showing that the North Pole is gonna be in the dark aqua, about 1.5 meters thick. And see the green? That's really thinning down and breaking up. And that thicker ice is just being whittled down. And as it melts out, our thickest ice is going to be left right along this Greenland coastline and the Canada coastline. Just that little area, like a little arc. Here we're seeing open water in a lot of the Beaufort Sea by next Saturday. And see, it's going into light aqua, sweeping down in quadrant 1 and thinning out more in this Laptev Sea and moving across. So let's go back. Here we are today. So I'm going to click through just day by day and we can see the changes. Here we go. Look at that. Yeah, this is in high melt. Usually melts a lot, shockingly a lot, in July, and then it starts slowing down in August. It still keeps melting, but it slows down. And the melt continues until usually around mid-September when we reach minimum. And that would be at the end of the summer. And now we're hopping down to the Antarctic. So here in the South Pole, we're watching the refreeze, and here it's coming out a little more, inching out. Our majority of thicker ice is right here in the Weddell Sea. Into the bright aqua, a little bit of green, little hint of red here along the this western peninsula. And the Ross Sea, we can see a little thickening going into dark blue. So about 1 meter thick there. Now, usually it doesn't get real thick Now it's dark down here, but the days are getting shorter. And I mean, the days are getting longer. That's what I meant to say. So it's still inching out just a little bit. See? And during their summertime, most of this ice melts and then it has to refreeze. And this is salt water rather than fresh water, which most of the Arctic is, although it's changing. And because of the water from the Atlantic and the Pacific are mixing in more and more in the Arctic. Now look at this. Look at how this ice is pulling away from that's pulling away from the ice shelf there. That's kind of disturbing. I don't think it should be doing that. Look, see that? That's in the forecast period. See, I stopped it at the end. See, it's pulling away. Why would it do that? And, you know, I don't know why the ice drift would be that intense to pull the ice away. But it definitely pulls the ice away from the ice shelf. So that must be the ice drift. If anyone has any ideas about that, just leave it in the comments. Now we're moving on to National Snow and Ice Data Center. This is Arctic sea ice concentration. Wherever the blues are, that's where it's melting. And the darker blue it is, the more it has melted and the less concentrated it is. So here in the Hudson Bay, you can see that's almost all gone. This west side of Greenland is all melted out. This kind of brownish line is the median. And so we're well under the median on this east side, and here in the Laptev Sea, and here in the Chukchi Sea. And now we are seeing a little bit darker blue swoop down here in the Beaufort Sea, where it shows the hole on the other model on Climate Reanalyzer. But I'm not seeing open water here. We are seeing more blue here above Greenland, so that's kind of melting out too. And here next to the North Pole. Here's the Arctic sea ice extent. This is as of yesterday. The blue line is this year, the dotted line is 2012, and the gray line is the median. So we're about at, it looks like 9 million square kilometers right now. on extent, and they count everything. They count every little wisp, even if it's just a little inkling of ice. They count it as extent. Okay, here's the Antarctic sea ice concentration. Again, the brown line is the median, so we're under that this year. And here's the blue line for this year. This is on the refreeze. And the green line is last year. We're still well below last year. And we're running kind of parallel with this median right now. Now, Greenland. Fasten your seat belts. This has been in high melt this week. Here it is. Yesterday, all the salmon color is where it's melting. Look at that. See, it's coming in further inland on this north end and on this southwest end. Here are the cumulative melt days so far this year. And one day we saw it all the way across the interior one day, all the way down here, like across about a third of the way up. So see, it's already melting interior all the way up to here. At least one day so far this year. Here's the chart for the extent, melt extent. So this week has just been going up. We spiked out here a couple of days ago at about 26%, and then we were at about 18%. Now we're, or 19%. Now we're about 20% melt. So it's way above this dotted blue line, which is the median. That's all of those. Now we'll move on to NASA Worldview. Let's go down to the Antarctic. Here, see, it's still in the dark. But we're going to turn on our nighttime layer. And look, it's pretty good today. I mean, well, it's really excellent. This layer has been really weird looking recently. So I'm tracking this iceberg A76. This broke off in the Weddell Sea, and I've been tracking it, and this is ice around it, but there's open water around it, so it's still showing movement. Considering that the sun is going to be coming up down here. It won't get frozen in very long. Here's this tippy point of the Western Peninsula, but it is surrounded by ice right now. So let's go back to last Sunday. So here it was. Last Sunday, the 3rd. Let's see what it did this week. Here's the 4th. It's kind of dark. It's the 5th. There's the 6th. Still dark. 7th. 8th. Here's the 9th. And then today. So it's kind of in a holding pattern right there. And here's these Larsen ice shelves. And methane is coming up all through this ice. Right down here, this hole, that's where that iceberg A76 broke off. You can see the indentation. And so, according to the Navy model, the ice is going to be pulled away from the coastline here this week. So we'll be watching that. Here's the Brunt ice shelf. We're looking through some clouds here. Here's the north end. This is like daylight almost. You can see the ice out there. Okay. Here's the Amory ice shelf. Let's see. Kind of lost. Where'd it go? There it is. Right down here. Look at that. See, not much ice right up around it. So that's just really thin ice right there. Then coming around. Here's the ice edge, see? So there's not much around this east side. See, not much at all. And here, coming around the southern, this is the Ross Sea here. Look at this. These reflections are weird looking. Look at this. Here's Ross Island. This is an excellent view. This is Mount Erebus volcano. Here's the ice. Right up here is McMurdo Station. You see the little light there. And here's the Ross Ice Shelf. Here's the Ross Sea. See, there's open area right next to the ice shelf. Open water. Let's come on around. Right down here. Here we are. I got lost. I'm in the dark. This is the Thwaites Glacier there. Look. Here it was a couple of days ago. See that it's broken off. The tongue is broken there. And Pine Island Glacier is up here. Can't really see that. So we can't really see that right now. And we're back to where we started from. So that was an excellent tour. Excellent view in the dark. Now we'll hop up to the Arctic, and here's our sea ice concentration layer. Here's our blue marble layer. And what we're seeing, so we've got a little area where it's melted down a little more that would correspond with the hole that Climate Reanalyzer is showing. But it's not just all wide open water there. See, it's just not. So wherever you see colors, it's melting. Here it's in high melt in the Chukchi Sea. And see, look up here by just north of the North Pole. Wherever you go into yellow and green, you'll be able to see holes when we go to the satellite view. Look at all this melting in the tributaries. So, let's see what happened this week. Go back to last Sunday. Here we were. Here we go. Here's Monday. Look at that. Tuesday. Wednesday. Thursday. Friday. Saturday. And here we are today. So we'll turn our layers off. And look at the haze. See, it's coming up from Alaska all the way across. See, you can see it hazy all the way past the Hudson Bay, Canada. All of this archipelago is in smoke, and you can see the Beaufort Sea. See the grayish color? That's the smoke. So we have to look through the smoke to see the ice. And it's coming apart. See there. See, we can see some open water here, and then the pieces. Look at this smoke. See, here's open, and then here's Canada. And see where this ice is melting. Gets kind of greenish as it gets thin, as it's melting. Here's Ellesmere Island. See. Here's the nearest strait. Here's Greenland. And I don't know how this Lincoln Sea just magically filled up and became frozen like that. When during the winter time we saw a lot of open water up here. I just don't understand how that happened. Now here's the nearest strait. Okay, here's a cloud. We can see the ice. See, there's a cloud. Let's go back. Here it was yesterday. That's a better view. See? Moving out. Then, here's the Baffin Bay. Here's Greenland. Here we are today. There's a cloud. There's no ice along this Greenland coastline. And you can see where it's melted over here. See? And here's the east side. Very cloudy. Here's Svalbard. Let's see what we can see here. Alright. Here you can see the ice breaking up. See the green? That's algae. See? Here's Franz Josef Land. No ice on the right side. Here's Novaya Zemlya. Here's a little wisp. See? Right next to the island. And a little bit up north. This is all open. This is the Kara Sea. This was red and brown on Climate Reanalyzer for 2-meter temperature. Sea surface temperature anomaly. Here's the Yamal Peninsula, and look in the water. That's all brown. This is the Gulf of Ob. That's all melted. This is the Kara Sea. Most of this is open. Let's go back. Yesterday. So here we are today. Here's some ice. Here's Severnaya Zemlya. See, here's open water. Here's Komsomolets. This is the area around here where the methane is just billowing again. And there are ice caps on these islands. Here's the Vovolov ice cap. It's flowing into the ocean. Once this ice melts out a little bit, you'll be able to see the flow of ice into the ocean. And then coming up, this is the Laptev Sea. And look at this, open. Let's go back, see what we can see. Look at this, open, open, open. Here's New Siberian Islands. See, this is really opening up around there. And along the coastline, see. Here's this East Siberian Sea. There's Wrangel Island. And here's the Bering Strait. That is open. There's no ice there. Let's see, look at this. This was Friday. Look at that. And here's some ice. But see how it's melted in? Look. Here's Alaska. Here's the Beaufort Sea. So here it was on Friday, coming apart. And more smoke. So it's been smoky up here for, I don't know, a couple of weeks now. Week and a half at least. And here we are today. See, here it is. And then back to Canada. Ellesmere Island. Greenland. Now let's see what else we can see. Okay, here, look at this. Look at all that open water. That's at, what is that, 87 degrees north latitude. And I found if I zoom in enough, the zippers show up. See? See the zippers coming down to the 0 point, or 90, which is at the North Pole, and they twirl. See? It's like they're rotating. See? They're not straight. There's open water. Open. Look at this. So it's just thinning down mainly. Thinning and starting to come apart. So there's that. Now we'll take a peek at earthquakes. We've got 214 worldwide right now. Let's go 7 days, all magnitudes. So this week there were 2,105. We had an Arctic earthquake up here by Jan Mayen, 4.5. This came in on the 7th. And look at a lot of activity in the Aleutian Islands. And we didn't have a lot of huge earthquakes. Let's see. Let's just get a 4.5 magnitude or higher for the last week. Fours, five, a few fives. So we didn't have any sixes this week. There were mainly fours and a few fives. Normally we have at least one 6, 6.0. Now we did have had a cluster here at the Mariana Islands. Look at all of this. 17 here. That happened this week. Here's some activity around Fiji. Here, Indonesia. And we had here in the Andaman Sea, we had 40 stacked up. These are 4s and 5s. So that's a little unusual. I'm going to turn on all magnitudes, 7 days. We had kind of an unusual one here in Germany, 4.0, Rangendingen, Germany. That came in yesterday. Look, this just came in. 4.7, Armenia. See, anywhere you have red lines, you've got earthquakes. And also this little area in the Bering Sea, see, it's just north of the Aleutian Islands. How many was there? 7 here. These were 3s, 4s, and a 5.3 was the largest. St. George, near St. George, Alaska. So we're having these clusters in some unusual places. Then Look at all of this. Here's Yellowstone. Up here is the Cascadia zone. We had a bunch at the bottom of the Juan de Fuca plate and the Fulcrum Point. Look, all the way along the San Andreas fault line and Ridgecrest, Searles Valley up through Walker Lane. Let's see. This is just all moving. West Texas, Oklahoma, New Madrid area. We had 3 in Tennessee. 4. There's 4 here. 2s. Yeah, okay. And South Carolina at Elgin, we had 3 here. Small ones. So, a lot of activity. A lot of plate movement. So that's my report for tonight. And I always like to bring it back to a spiritual focus. And we're reading out of the Book of Wisdom. This is from the Apocrypha. And it was written by King Solomon. Wisdom chapter 9. O God of my fathers and Lord of mercy, who hast made all things with thy word, and ordained man through thy wisdom, that he should have dominion over the creatures which thou hast made, and order the world according to equity and righteousness, and execute judgment with an upright heart. Give me wisdom that sitteth by thy throne, and reject me not from among thy children. For I, thy servant and son of thine handmaid, am a feeble person, and of a short time, and too young for the understanding of judgment and laws. For though a man be never so perfect among the children of men, yet if thy wisdom be not with him, he shall be nothing regarded. Didn't mean to do that. Here we go. Thou hast chosen me to be a king of thy people, and a judge of thy sons and daughters. Thou hast commanded me to build a temple upon thy holy mount, and an altar in the city wherein thou dwellest, a resemblance of the holy tabernacle, which thou hast prepared from the beginning. And wisdom was with thee, which knoweth thy works, and was present when thou madest the world, and knew what was acceptable in thy sight, and right in thy commandments. O send her out of thy holy heavens, and from the throne of thy glory, that being present she may labor with me, that I may know what is pleasing unto thee. For she knoweth and understandeth all things, and she shall lead me soberly in my doings, and preserve me in her power. So shall my works be acceptable, and then shall I judge thy people righteously, and be worthy to sit in my Father's seat. For what man is he that can know the counsel of God, Or who can think what the will of the Lord is? For the thoughts of mortal men are miserable, and our devices are but uncertain. For the corruptible body presseth down the soul, and the earthy tabernacle weighteth down the mind, that museth upon many things. And hardly do we guess aright at things that are upon earth, and with labor do we find the things that are before us. But the things that are in heaven, who hath searched out? And thy counsel who hath known, except thou give wisdom, and send thy Holy Spirit from above? For so the ways of them which lived on the earth were reformed, and men were taught the things that are pleasing unto thee, and were saved through wisdom. Wisdom chapter 9. We need wisdom. We need wisdom. We need discernment, we need guidance, we need protection, but mainly we need God and Jesus. We need their blessing, and we need to know that we'll be in our Father's kingdom once this is all over, said and done. If you haven't given your life to Jesus Christ, I highly recommend it before it's too late. So I hope everyone has as good a week as they can. And Lord willing, I'll do this again next Sunday. So I love you all, and I'm praying for you. And until next time, God bless you. Go in peace, and I will talk to you soon. Good night.